Hello and welcome back. Alright, now we'll be talking about the loss functions used in neural networks. Now, loss functions are sometimes called cost functions also, especially in convolutional networks, but they're basically the same. So, this tutorial, this video, will learn how to calculate and use the loss functions. Okay, we'll look at the famous loss functions that are widely used in neural networks. Now, before we move on, remember something very important, that the whole objective from our neural network and from the training is to minimize the loss. So what we're doing is calculating the loss, which we'll learn how to do in this video. And then after we calculate it, we train the network, we adjust the weights of the network in order to minimize that loss. Okay, between the predictions and the actual outputs or the expected outputs. So that is the whole purpose. So let's move on, and we'll start by the mean squared error. The mean squared error is one of the simplest and also widely used costs in neural networks. So the concept is very simple. You just take the difference between the actual output and the predicted output, which is this term over here, and you square it. So this term over here, which is the difference between the actual output and the predicted output, is just the error. So you just take it and you square it. So you square the error, and then you add them up for all your training samples, and you take their average. So you sum them up and take their average. So let's say that you have 5 training samples. So that means you calculate the error for each sample. So I here is the number of sample, and as you can see, I equals from 1 until n, where n is the number of training samples. So you calculate this term, you square it for the first sample, and then you go ahead, you calculate it again for the second sample, third, fourth, and fifth. You add them all together, and then you take their average, you divide them by n, which in this case is 5. So that is the mean squared error. Very, very simple. And so y hat is the predicted output, which is this term over here. Y without the hat is the actual output. And n is the number of training samples in each batch. Now, if you're using a mini batch training, that means for example, if your training samples is 1000 and you're using a batch of 100, that means you need to iterate 10 times. So in each iteration, there's 100 samples, so n is 100 if you're using mini batch. If you're not using mini batch, then that means you're just taking all your samples at once, so n is just the number of training samples. Alright, so I'd like to emphasize something, that no matter if you put y hat here or here, so if you switch these two, it doesn't matter because you're squaring it at the end. So if you get a negative answer or a positive answer, when you square it, you get the same thing. So it just doesn't matter if you put the y hat here or here. Okay, so now let's talk about some variations of the mean squared error. So some of the variations, sometimes people use half of the mean squared error. This is the one that we saw in the first section in this course when we're discussing the backpropagation. And the whole purpose of putting a 2 here is that when we're deriving this, so remember in the backpropagation during the application of the chain rule, we are deriving the error with respect to the weight. Okay, so the first error with respect to the output, when you derive this equation, then the 2 comes down here, right? So when it comes down here, it gets removed with this 2. Okay, so this whole term, 2 divided by 2, just gets removed, and you just end up with 1 over n and your error. So that's the whole purpose of using half of the mean squared error, is just to not affect the error when you're deriving it. But as I've seen from my experience, it's not gonna really matter. Okay, the results might differ, but it's not that important to emphasize. Okay, but just to know, sometimes people do use half of the mean squared error, so they just divide it by 2. Now the root mean squared error is just your MSE, your mean squared error, but with a square root. Okay, so you just square root this MSE loss function. Okay, so it depends on what your application is, and there's also other variations, but I just chose these two. Okay, you can definitely look them up if you're interested. Before we end this video, let's look at one example of how to calculate the mean squared error. So let's say that you have three samples, and this is the result that you got from your neural network. So these are the prediction results, and these are the actual results that you have. Now this is the error. Simply you just subtract these two from each other. So 48 minus 60, you get negative 12. 51 minus 53, you get negative 2. And 57 minus 60, you get negative 3. And if you square these up, you get 144. So negative 12 squared, 144. Negative 2 squared is 4, and negative 3 squared is 9. And now all you have to do is just add all of these up. You add the squared error. So 144 plus 4 plus 9, okay, it gives you 157. Then you divide them by n. In this case we have 3 samples, so n is 3. So 157 divided by 3, and you get 52.3. Of course this is a big loss, and now you need to minimize it. How do you do that? By training the network. Okay, so one note on the side also, if there's more than one output neuron, so this case is just for one output neuron. But if there's more than one output neuron, then you'd add the error for each of the output neurons. Okay, so you take the error for each output neuron, you add them all together in each of the training samples. So this is the new equation of the MSE when you have more than one output neuron. It's just your MSE, which is this term over here. Okay, this whole guy is your MSE. Okay, and this whole guy is just how many output neurons you have, which is J. So J is the number of output neurons. So you just take the MSE for each neuron, okay, and then you add them all together. And that's it for the mean squared error. Thank you very much, and I'll see you next time.